Ladies and gentlemen, welcome. This is 4ST601 Statistics in English and our third seminar. Today we will start with a simple and easy example about the weighted version of arithmetical mean, and after we will continue with measures of variability. So I believe that we can start. There we have the first example. There are given average monthly expenditures on food of two types of households according to their main income source. So we have two types of household: employee and self-employed. What are the average monthly expenditures on food of all 31 households in the population, or we can say in our sample? Yes, this is our sample of 31 households. So we must know that we have to use the weighted version of arithmetical mean. So I will use the screen, the whiteboard, and I will calculate this for you. Okay, so I will rewrite on the whiteboard what was on the screen. NJ frequencies, yes, absolute frequencies, 18 and 13 households, and individual XJ with stripe, individual averages, 4,928, 4,988, and the self-employed 6,077. Okay, so there I have the data set, and the total mean X with stripe must be calculated like summation through all J, XJ with stripe, weighted by NJ, divided by, and there is summation through all J and J. Yes, so it's necessary to weight, yes, these averages by absolute frequencies. So this is the reason why we have here written another column, XJ with stripe, weighted by NJ. Okay, so 4,988 weighted by 18. Yes, so there will be 89,784, and now 6,077 weighted by 13. Okay, 79,001. Okay, summation, yes, summation of these two values, plus 89784, enter. So 168,785. So this is the numerator and denominator. If you remember, there is a summation, yes, and there is 31 households, yes. So I have here 31 households in denominator. So this divided by 31, and the total mean, total average, X with stripe, is equal to 5444.68. Yes, probably Czech crowns. Yes, so this is the weighted mean, the weighted average, and we used this weighted version of the formula. We will continue with another example about sugar industry. There are three firms in the sugar production industry, and we know the average wages in each of them. So we have here firm number 1, number 2, number 3. And there is a question, what is the average wage in sugar industry in total? Yes. Where is the relative variability of wages the lowest? So we have here a data set of 3 firms. Average wage in the particular firm, yes, XJ with stripe. We have here 25,600, 24,700, and there is the lowest average, individual average, 23,200. We have here absolute frequencies, NJ, in this situation, number of employees, which you have, yes, in the particular firm, in firm 1, 2, and 3. And we have here calculated individual variances, SJ, for the particular firm squared, yes, it's variance in squared units, yes. Do you remember on the previous seminar I said to you that it's very difficult to interpret the variance because this is not in Czech crowns, yes, this is in some squared units, and it's very difficult to interpret the squared value, yes. So we will calculate the total average, and after we will calculate 3 partial variation coefficients, because there is written where is the relative variability the lowest. We must know that we have absolute measures of variability, for example standard deviation, variance, or variation range, yes, absolute measures of variability, and one relative measure, and this is variation coefficient. So we'll calculate 3 variation coefficients and we will compare these coefficients. Okay, so I will write here that we have firm number 1, number 2, and number 3, and we will denote individual averages xj, yes, with stripe, and there was 25,600, 24,700, and the lowest individual average 23,200, yes. Number of employees, NJ, is absolute frequency, and we have 150 employees, 200, and 500, yes. It's possible to calculate summation here, because we can calculate the sum, the total number of all our employees, 500, 700, 850, yes, 850. And now, according to our well-known formula, x with stripe is equal to, and there is summation through all j, xj with stripe weighted by nj, yes, divided by summation through all j and j. We are able to calculate the total mean, yes. So 25,600 weighted by 150 plus, because it's a summation, yes, here. 24,700 weighted by 200 plus 23,200 weighted by 500 equal sign. Yes, this is numerator. We know that multiplication has bigger priority than summation. So 25,600 times 150 plus 24,700 times 200 plus 23,200 times 500. 100. So the numerator 203, 8, and now 0, 0, 0, 0. This is numerator, and denominator is 850 employees in total. Yeah, so if we calculate this divided by 850 divided by 850, we have the total mean, the total average in sugar industry. Yes, so this ratio equal sign is divided by 850, 976.47 Czech crowns. Yes, so this is the weighted mean, the weighted average, and you can see that this mean is between this value and this value, and the reason is because we have here the largest number of employees in the third firm, in the third company, yes, here. So there is the greatest, the largest weight, yes, on this individual average. So this is the reason why the total mean is 23,976 Czech crowns. Okay, so this is the total mean, and the variation coefficient. Variation coefficients, 3 variation coefficients, yes. We can calculate variation coefficient like a ratio, yes, of the standard deviation as x and individual mean x with stripe, yes. In our situation we have 3 firms, so there will be J, there will be J, and there will be J, yes, indices. Okay, so what do we need? We have variances, yes, individual variance as x j squared, yes, individual variances. So 250, yes, 30, 360, 360, yes, and finally 15, 480. We know these individual variances, yes, but for the calculation of coefficient of variance, variation coefficient, we need to know standard deviation, yes. So standard deviation as xj only. We know that standard deviation is calculated like square root from the variance. So it's very easy because we can easily calculate here square root from 12 to 50, square root from 30, 360, and here square root 15, 480. So we will receive 3 standard deviations. So where is square root on the calculator? Here. Square root 12 to 50. Enter. I will use only 2 decimals. Yes. 110.68. 68. Square root from 30, 360, 174.24, and we can continue. Square root from 15, 480, 124.42. The deviation, the standard deviation, is in Czech crowns, yes, in the basic units. So it's easy to interpret standard deviation, yes. Czech crowns, Czech crowns, Czech crowns. It's absolute measure of variability, absolute measure in the basic units. Now we can calculate three individual coefficients of variance, variation coefficient, yes. So I will delete this part, yes, and there is firm 1, 2, and 3, yes, and we know that coefficient of variance is calculated like standard deviation divided by the average, the mean. So for the first firm, 110.68 divided by the first mean, 25,600. Yes, there will be first coefficient of variance. We will continue. 174.24 divided by, which means this one, 24,700, yes, 24,700. And finally, the third one, yes, this deviation, 124.42 divided by this mean, 23,200. Equal sign, equal sign, equal sign, yes? So now I will solve this. 110.68 divided by 25,600. It must be relative numbers, so 0.00432. We can continue. 174.24 divided by 24,700. 705. And finally, 124.42 divided by 23,200, 0.00536. Okay, so we have here three individual variation coefficients which can be multiplied by 100 and interpret in percent. Yes, we can interpret this in percent like 0.432%, 0.705%, and 0.536%. Okay, so this one is the lowest, this one is the largest, the highest, and I forgot the question, yes? What was written here on the screen? Where is the relative variability of age is the lowest? The lowest relative variability is the lowest here in the case of first firm. Yes, in the case of first firm, there is the lowest relative measure of variability. If you check this, for example, standard deviation of variance, absolute measure of variability, there is also the lowest absolute measure of variability in the case of first firm. Yeah? So either absolute measure or relative measure in this situation, in this concrete situation, yes, the lowest variability in the case of first firm. So that's all. We will continue with another example where we don't know the data set. Yes, we don't know the data. We know only that calculated variance. So Sx squared, yes, variance, calculated variance is 3.5, yes, units, squared units. Calculate new variance after each observed value in our unknown data set, data file, yes. After each observed value in the statistical sample is increased by 1, is doubled, and is decreased by 10%. So we must know the basic characteristics of variance. Yes. So I will show to you these operations, yes, on the whiteboard, and I will show you some illustrations. So it will be good to illustrate this on the whiteboard. We know only that calculated variance Sx squared is equal to 3.5, yes, but we don't know the sample, yes? So this is just illustration from me, yes. I can expect that I have here, for example, value 2, 4, 7, 9, 3, 5, and I don't know how many, yes, so the values, and there are 3 questions, yes. Calculated variance is 3.5, and what will be with this variance if each value, yes, each observed value in the statistical sample is increased by 1. So for example, what happened if I write here plus 1, etc. So instead of 2, there will be value 3, value 5, value 8, value 10, value 4, value 6, etc. Yes, so we know that the variance Sx squared is calculated like summation through all E or all J, yes, summation through all J of square differences between xj and arithmetical mean, and this is divided by number of observations. Yes? We don't know how many observations we have, but important is that if I increase everything by 1, the number of observations will be the same. Yes? If I increase everything by constant, each value in the statistical sample by constant, it's important to know that I have calculated some mean, and this mean will be higher by this constant. So I had here differences and square differences before this change, yes, and after each unit in the statistical sample increased by 1, arithmetical mean also increased by 1, so before changes, after changes, these squared differences are the same, yes. Denominator is still the same, so the variance will not change, yes? The variance will be still the same, as x squared will be equal to 3.5. Yes, so this is response A. Yes, different situation is in the case that this increasing is not by constant, yes, but is, for example, a multiplication. Each unit will be doubled, yes, multiplied by 2. So I will delete this. Yes, and the change now is that everything is doubled, multiplied by 2. So instead of value 2 will be 4, yes? there will be 4 times 2, 8, 14, 18, 6, 10, etc. Yes? We must remember very important definition. If all units, yes, all units in the statistical sample are multiplied by a constant, the variance is multiplied by square of this constant. Yes? So in our situation B, yes, everything is doubled, so times 2, the variance will be multiplied by square of this constant because the variance is in squared units. So 4 squared is equal, 2 squared is equal to 4. So the variance, new variance will be 4 times 3.5. 3.5 and 3.5 is 7. 7 times 2 is 14. So the variance will be 14. So this is response B. Yes, and C is, I think, decreased by 10%. Yes, decreasing by 10%. What is it decreasing? Decreasing by 10% is multiplication by 0.90. Why? You have, for example, prices in the store without taxes. Yes, and tax is I don't know, 15%, 21%, yes, etc. So if you want to know the price with taxes, yes, you must multiply these prices in the store by value 1.15. If you want to increase the price by 15%, yes, or multiply by 1.21, yes, if you want to increase the price by 21%, etc. And this is decreasing, relative number. What is below 1 is decreasing. So, if everything will decrease by 10%, yes, so everything will be multiplied by this constant. So multiplication 0.90, yes, multiplication 0.90, and there will be new value, yes, new values. Okay, so it's the same like in the case B. So C, we must remember the definition. If all units in the sample are multiplied by constant, the variance is multiplied by square of this constant. So 0.90 squared, 0.9 squared is 0.81. So this is 0.81. And I will write here 0.81 multiplied by original variance, yes, 3.5. Okay, so times 3.5, enter, 2.835, 2.835. So this is response C. So there is A, there is B, and there is C. So please remember the two definitions, yeah, which you have written in my Microsoft Excel file. We will continue with this example. Again, we don't know the data set, yes, the data inside this statistical sample. We know only that from 20 values we calculated the arithmetical mean 45. and variance 169. Two values from this statistical sample, from this sample of 20 values, yes, were used incorrectly. Instead of value 18 should be 30, and instead of value 75 should be 80. The other 18 values are set correctly. Calculate how the mean and the variance will change when we repair these two incorrectly set values. So there is a table where we know the sample size, the variance and the arithmetical mean, and there you have the tables for the calculation of the correction. I will do this for you on the whiteboard because I'll have to use the formulas from your formulas sheet. Okay, so I know that n is equal to 20, and again, for illustration, yes, I don't know this data file, yes, variable, for example, xe, we have here values 11, 31, 5, yes, and there, for example, 18, 22, 75, etc. Yes, I don't know these data sets, yes, but I know that there is incorrectly set value 18, and instead of value 18 should be 30, yes, and instead of value 75, yes, am I right? Yes, 75 should be 80, yes. So I have here 20 values, 18 values are set correctly, and we know that instead of this value and this value should be something else, yes. And we know that originally calculated average is 45. Yes, and originally calculated variance as x squared is 169. So I must know that the mean x with stripe is calculated like summation through all e xe divided by n. Yes. Okay, so I know this average and I know this sample size, so I'm able to calculate this summation. Yes. So the summation through all e xe is calculated like the mean multiplied by n, sample size. Yes. In our situation, 45 times 20 is equal to 45 times 20, 900. 900, yes. So this is the summation of xe. Sum of xe through all e, yes. Okay, and I know that inside this summation, yes, is wrongly set 18. So I will take 18 out, yes, and instead of 18 I will add to this summation the correct value 30 plus 30, yes, and I will continue with modification of this summation, yes, so minus 75, yes, and instead of 75 there should be value 80, yes. So we can modify this summation, and after we have calculated new summation through all e xe. So please calculate with me. 900 minus 18 plus 30 minus 75 plus 80. 917, yes. So 917 is the new summation of xe. And now we will return to this basic formula, the new mean. Yes, x with stripe nu will be calculated like this summation 917 divided by number of observation. I replaced this number by this number and this number by this number, so new sample size n is still equal to 20, yes? Okay, so divided by 20, and there will be new mean. Divided by 20, new mean is a little bit higher, yes? 45.85. Original mean was 45. The new mean is a little bit higher because I changed these values, and all values were higher than original values, the wrongly, the incorrectly set values. Yeah? So this is the reason why this mean is a little bit higher. Yes. And now the variance. It's necessary to check your formulas and find here the computational formula for the variance. Yes? Computational formula Sx squared is x squared with stripe minus x with stripe squared. Yes? Please try to find this in your formulas, where is written that the variance can be calculated like difference between the average, the mean, from squared values of the statistical sample, yes, and second power of the mean, yes, of average. Okay, so I will rewrite this like Sx squared is equal to, I will rewrite this like summation through OE xe squared divided by n, yes, so this is the first part, minus x with stripe squared, yes. Okay, so we can put this on the left side, and this is in denominator, and on the left side this will be in multiplicator, yes. So s x squared, can you see this minus? There will be plus x with stripe squared. Can you see this division? Yes. So parenthesis, parenthesis, multiplication by n. And what is here on the right side? This summation, so equal sign, summation through all e xe squared. Okay. Do you remember when I tried to change the mean, I needed summation through all e xe. I would like to modify the variance, so you know that variance is in squared units. So we need summation of xe squared. Yes? And this is the reason why I have here this summation of xe squared expressed by this formula. Yes? So I will delete this and we will solve the original old summation of xe squared. Yes? So old variance 169 plus original mean, original average 45 powered by 2, yes, times n original size of the sample size, yes, 20. So this will be equal to summation through all e xe squared. Okay, so 45 squared plus 169 multiplication 20, and the result is 43,880. So this is summation through all e xe squared. Yes? And again, do you remember when we modify this summation, yes, without squares, we take something out and we put something in, yes? Now we must modify summation xe squared. So there is wrongly set value, yes, 18, but not only 18, but 18 in squares, yes? And instead of this value 18, you must put here value 30, but not only 30, but 30 in squares. Because everything here is in squares, because we are trying to modify the variance, yes? And we can continue again, minus 75, but not only 75, everything is in squares. So in squares, and we must put here plus value 80, but not only 80, but 80 squared, yes? And you will receive summation through all e xe squared new, yes, new version of this summation. So please calculate with me 43,880 minus 18 squared plus, use parentheses, yes, it will be better for you, plus 30 squared minus 75 squared plus 80 squared. Okay, so this new summation is 45,231. Yes, so we calculated this new summation. And now return to this computational formula. Yes, we will return to this computational formula. I will write here one more time as x squared is calculated like there is summation through all e xe squared divided by n minus x with stripe squared. Yes, this formula was written here, yes, few minutes ago. So we need more space, so I will delete this, and we will calculate the new value of the variance. Yes, so equal sign my new summation of xe squared. Yes, so 45,231 divided by I changed, yes, the value by value, so the sample size is the same. Yes, so there we have still 20. So there is new summation, yes, actual value of sample size minus new value of calculated arithmetical mean powered by 2. Where is my new mean? I deleted this value, yes, but you remember that x with stripe new was equal to, it was written here, 45.85. Yes, do you remember this? So minus 45.85 squared. Okay, so this divided by 20 minus 45.85 squared, enter. So the new variance as x squared is equal to 159.3275. Yes, so the new variance is a little bit lower. Yes, original was 169, the new one is 159 and something. We will continue with another example. During one working day, 35 people saved in the bank in total, yes? 140,000 Czech crowns. Variance of these deposits was 9 millions. This is variance, so we must know that this variance is in squared units and we are not able to interpret this value, yes, because we don't know what is it squared Czech crown, yes. Okay, in the same day, in the same working day, more people, 73 people withdrew a little bit less in total, 138,000 Czech crowns with variance 3 millions, yes. And there is the question, was this day higher relative variability of deposits or withdrawals? So, again, we must know that we have only one measure of relative variability, and this is variation coefficient, yes? The variation coefficient, so we must calculate two variation coefficients and compare these coefficients between them. Okay, so I will rewrite what is on the screen. Do you remember that we had here deposits, yes, and withdrawals, yes, two types of operation in the bank, yes, and number of clients, yes, can be denoted, for example, NJ, yes, we can use NJ, and we have here 35 and 73, yes, 35 clients put the money to the bank, and 73 clients withdraw money from the bank, yes. The summation, total amount of deposits and withdrawals can be denoted like summation through all j xj, yes, summation of all values. So there is 140, and if you want you can use zeros, yes, 0, 0, 0, and there we have 138. If you require 0, 0, 0, yeah, this is in thousands. And finally, we have here written the variance s x j squared, yes, and there is 9 millions 0, 0, 0, 0, 0, 0, yes, and 3 0, 0, 0, 0, 0, 0. Okay, so we know this, yes, and the question is about relative variability. We know that variation coefficient is calculated like a ratio, standard deviation, and arithmetical mean, yes. So it's very easy for us to calculate standard deviation, because standard deviation Sxj will be calculated like a square root from Sxj squared, from the variance, yes? So it's very easy to write here Sxj, the partial individual standard deviation for deposits and for withdrawals. So the square root from 9, is 3. This was in millions, so this will be in thousands, yes? 0, 0, 0, and standard deviation is more comfortable for us, more comfortable in case of interpretation, yes? 3,000 Czech crowns, we can imagine the value 3,000, yes? And here, square root from 3 is 1.3 732, yes, but in thousand it will be 1732, yeah, so this is the deviation. Okay, so we have here two deviations and we need to calculate the mean, individual means, the partial means, xj with stripe, yes, and this will be calculated like summation through all j, xj divided by n, yes. So again, we can easily calculate two ratios, 140,000 divided by 35 clients, yes, and 138,000 divided by 73 clients, yes. So here, xj with stripe, there we calculated these means. 140 divided by 35, this is easy, 4,000, yes, 4000, so you can interpret this like average deposit per this day, yes, and 138 divided by 73 is 1.89. So this will be interpreted like 1,890 Czech crowns. So this is average value of withdrawals. Yes, average withdrawal amount of money. Yes, on this day, working day. Okay, so now we can calculate these ratios. So in the first case, in the case of deposits, 3,000 divided by 4,000, and in the second case, case of withdrawals, 1,732 divided by 1,890. So this is very easy, 3/4 should be 0.75. So this is the first variation coefficient, Vxj. Yes, variation coefficient 0.75. And the second one, 1,732 divided by 1,890, 0.916. 0.916. Okay, so this is the second one. Yeah, it will be written here 0.916. You know that it's possible to multiply these variation coefficients, multiply by 100 and interpret in percent. So there is 75% relative measure of variability, there is 91.6% relative measure of variability. So the question, was at this day higher relative variability of deposits or withdrawals? Relative variability is higher in the case of withdrawals. Yes, in the case of withdrawals. Compare with absolute measure of variability, for example, variance or deviation. Absolute measure of variability is lower in the case of withdrawals, but relative measure of variability is higher in the case of withdrawals. Yes, in our situation. Are you able to see this example? 3.6. The average wage of workers, for example, in Norway, because there we have units in Norwegian crowns. So the average calculated wage of workers is 23,000 Norwegian crowns. And the variation coefficient is 0.4. It's very important to know that variation coefficient can be given as relative number or in percentage, and there is written value 0.4. So I can expect that 0.4 is 40%, yes, 40% relative measure of variability. And the question, how the average wage and variation coefficient change if each worker gets added 2,000 Norwegian crowns, yes, at constant. So we know the calculated mean, average, and variation coefficient. And for illustration, I will demonstrate this again on the whiteboard. Okay, so I will write here that calculated mean 23,000 and variation coefficient 0.4. And now the illustration, yes, about wages in this company. So there is, for example, the boss, yes, the headmaster with wage, for example, 48,000 Norwegian crowns, yes, the vice boss, yes, with the wage 40,000 Norwegian crowns, the common workers, yes, the common workers with wage 23,000, 22,000, 21,000, yes, and some beginner, yes, junior worker, yes, with wage 16,000 Norwegian crowns, yes. So this is the structure, yes, of the wages in this company. We calculated this mean, this average, yes, and now we'll take a constant 2,000 Norwegian crowns, and we will increase each wage, yes, in this Norwegian company. So the boss will have 50,000, yes, the vice boss 42,000 Norwegian crowns, yes, and this beginner, yes, junior worker in this company will have 18,000 Norwegian crowns, yes. So this one will be probably the most happy, yes, in all company. So we must know how we calculated this variation coefficient. As variation coefficient is calculated like ratio, standard deviation, and arithmetical mean. Okay, so we can calculate original, old, standard deviation. Yes, standard deviation, old. Wait a second. Yes, the original standard deviation, like variation coefficient multiplied by the mean. Yes, so in our situation 0.4 multiplied by 23,000. Yes, okay, so please use the calculator. 0.4 times 23,000, enter. 9,200. Yes. So this deviation as x old, yes, is equal to 9,200 Norwegian crowns, because the deviation, yes, is in basic units the original values. Okay, so what happened with arithmetical mean? Here we have calculated x with stripe equal to 23,000, yes, and we took a constant 2,000, yes, Norwegian crowns, and we increased all values in the sample. So the new mean, which will be calculated here, x with stripe new, yes, will be higher by this constant. So new mean 25,000, 25,000, yes. Okay, so what happened with standard deviation? Yes, that is all the deviation. We know that standard deviation is calculated like square root from the variance. And do you remember our example with changing of variance and our two important definitions? If we add to all values, yes, in the sample a constant, the variance does not change. Yes? Why? Because the variance Sx squared is calculated like summation through all e, xe minus x with stripe squared divided by n. Yes? And now the mean is higher by 2000 Norwegian crowns. All values in our sample are higher by 2000 Norwegian crowns. So these differences will be the same, square differences will be the same, sample size is the same, so variance is the same, so standard deviation is the same, yes? Standard deviation is the same. Okay, so we will calculate new coefficient of variation coefficient. So this will be deleted, and here I will calculate Vx is equal to standard deviation 9200 divided by new mean, new average 25000. Okay, divided by 25000, and new variation coefficient is equal to 0.368. Yes, so the original variation coefficient was 40%. Yes, and the new variation coefficient is 36.8%. Yes, so the new variation coefficient decreased. It's very, very important to know how to interpret this change. Yes, we had all the value of the variation coefficient, and now we have a new value of variation coefficient. So variation coefficient old equal to 0.4. This is 40%. Variation coefficient new is equal to 0.368, and this can be interpreted in percent like 36.8%. Yes, and the question is about interpretation of this decreasing. One option is calculate the difference. Yes. 40% minus 36.8%. Result is 40 minus 36.8 minus result is 3.2. 3.2. But now the most important is we must know the units. Yes. If you calculate the difference of percentage, result is never in percent. Yes. Result is in percent points. Yes, percent points. This is the result. If you calculate the simple difference, you are able to calculate the ratio. Yes, the ratio new divided by old. If we calculate the ratio, we are using every time the relative numbers. Yes, so new 0.368 divided by 0.400. Yes, the ratio. I will calculate this. 0.368 divided by 0.4. The result is 0.92. I calculate the ratio using relative numbers, and the result is again the relative number. And what is it, relative number? Relative number is a number below 1, above 1, or equal to 1. If the result is 1, nothing changed. If the result is below 1, it decreased. If the result is above 1, it increased. Yes? In our situation, 1 minus 0.92 is equal to 0.08. It decreased by, and you are able to interpret this in percent. Yes? 0.08 multiplied by 100 is equal to 8%. 8%. So, new variation coefficient is 0.368. Old variation coefficient is 0.4. The new variation coefficient decreased by 8%. Or we can say that new variation coefficient decreased by 3.2 percentage points. This is very, very important, so please remember this interpretation and remember the difference between percent points and percent. Yes, percent points in the case of difference, percent in the case of ratio. Very practical example designed on interpretation of the change of the variation coefficient. Yes, what happens to the variation coefficient if the arithmetic mean increases by 1/10 and variance increases by 13%. So we don't know the sample, the statistical sample. We don't know the variance, we don't know the mean, we don't know the variation coefficient, but we would like to calculate the change. Yes? So I will use the whiteboard and I will calculate this ratio, the change. Yes? It's very important to know how can we calculate the variation coefficient. Yes? We know that this is calculated like ratio, standard deviation, and arithmetical mean. Yes? So, what was written here? What happened to the variation coefficient if arithmetic mean increases by 1/10? So, arithmetic mean x with a stripe increases by 1/10. What is it increasing by 1/10? It will be multiplied by value 1.1. Yes, this will be increasing by 10%. Yes, so this is increasing of arithmetic mean, and variance increases by 13%. Variance is sx squared, and this will increase by 13%, so the variance will be multiplied by value 1.13. Yes, so this is increasing by 13%. Yes, okay, so this is the calculation of variation coefficient, and you know how can we calculate the ratio. Yes, the ratio, the change, like new divided by old. Yes, This is the same in economy, yes? You will speak about the change of supply, change of demand, yes, etc., change of prices, and each change, yes, is calculated like ratio mu divided by all, yes? So, our new variation coefficient will be standard deviation multiplied by, there is variance, there you can see the second power, yes? So I must take this second power here out, so I must use the root here. This will be multiplied by square root from 1.13, because this is deviation and this is variance, yes? So new deviation divided by mean, x with stripe, multiplied by 1.1, yeah? So this is the new, divided by old, standard deviation divided by old mean, yes? Do you know what is it, division? Division is multiplication by reversed values, yes? Multiplication by reversed values, so I will write here Sx multiplied by square root from 1.13 divided by x with stripe multiplied by 1.10 multiplication by reversed values, yes? So x with stripe divided by standard deviation. Okay, this deviation can be crossed with this deviation, this mean can be crossed with this mean, and the result is a simple ratio square root from 1.13 and 1.10. Yes, so this will be the result. So on the calculator, square root 1.13 divided by 1.1, 0.9664, 0.9664. And what we calculated? We calculated ratio, yes? So the result must be a relative number. What is below 1 is decreasing. So it decreased by 1 minus 0.9664. Result is 1 minus this value 0.0336. This can be multiplied by 100 and interpret in percent. So there is decreasing by 3.36%, yes, it decreased by 3.36%. Why percent? Because we calculated the ratio and the result was relative number. We will continue with this example. We have two groups, yes, but we can have more groups, but in this simple example we have only two groups. Their frequencies within group averages, the means. It means individual averages for a particular group. And within group standard deviations, again it means individual standard deviation for the particular group, yes? And we would like to calculate the total average, the total mean, and the total variance for both groups together, yes? We don't know what is it if we have here boys and girls or cars and motorcycles. So just group A and B, individual averages, individual standard deviations, and absolute frequencies, number of units in group A and number of units in group B, and we would like to calculate the total average and the total variance. So we will do this. So there is rewritten the data set, and maybe you remember from the beginning from our today's seminar this formula for the calculation of the total mean, where we have here summation through all j, xj with stripe, individual means, yes, weighted by absolute frequencies and j, and in denominator we can see summation through all j and j, yes. So if we calculate this, 10 weighted by 30 boys or cars, or I don't know, yes, what we have here, group A and group B, plus 9 weighted by 20, yes, and this will be divided by 30 plus 20, so we have here the total mean, yes, in numerator 10 times 30 plus 9 times 20, numerator is 480 divided by 50, yes, divided by 50, and the result is 9.6, yes. So this is easy. This is the total mean, yes. I can write it, for example, here. X with stripe is equal to 9.6. And now, what about the variance? Mr. Hellman said to you that the total variance must be calculated like summation of two types of variance, within group variance and between group variance. So it's a decomposition of variance to two groups. I will write here that total variance will be calculated like s squared mean plus s x with stripe squared. So it will be a summation of two parts, the mean from variances, the mean from variances plus the variance of means, yes, and this can be rewritten like there we have summation through all j and individual s x j squared weighted by n j divided by summation through all j and j, yes. The first part, within group variability, the mean, the average, calculated from individual variances, yes, plus there will be summation through all j, and we have here differences between individual means, xj with stripe and x with stripe. This mean is this mean, yes. This must be in squares, yes, weighted by frequencies and j, and again this is divided by summation through all j and j. So this second part is between group variability. Within group and between group together is the total variability. So we will calculate this. So what we need for the calculation of this first part, I have here only deviations. So we must calculate s x j squared individual variances, yes. So squared values, 5 squared is 25 and 3 squared is 9. So now I have everything what I need for the calculation of this first part, yes, within group variability. So 25 weighted by absolute frequencies 30 plus 9 weighted by absolute frequencies 20 divided by 30 plus 20. Yes, you can see that it's not difficult. 25 times 30 plus 9 times 20, 930 divided by 50. Yes, the result is 18.6. Yeah, so this is the first part. This is the average calculated from individual variances. Yes, and now this second part. Yes. So what we need to calculate here, square differences, weighted square differences between individual means and total mean 9.6. Yes. So I will delete this and I will write these steps here. Yes. So the first part, first mean, 10 minus 9.6 squared weighted by number of observations 30. Yes. Plus, and the second row, 9 minus 9.6 squared weighted by 20 units. Yes. And this will be divided by 30 plus 20. Yes. Okay, so I will solve this. 10 minus 9.6 squared weighted by 30. So the first part is 4.8. Yes, 4.8 is this first part. The second part, 9 minus 9.6 squared times 20. 20. The second part is 7.2. Yes, so plus 7.2, and this will be divided by 50. Yes, divided by 50. So I will rewrite this here. So it's 4.8 plus 7.2 divided by 50, and the total result plus 4.8 divided by 50, 0.24. 0.24. Yes, so I have written here within group variability is this one, 18.6. Between group variability is 0.24, and in total plus 18.6 as x squared total. Yes, is equal to 18.84. So this is the total variance calculated on the basis of formula of decomposition of variance and calculated on the basis of absolute frequencies Nj. I will solve for you also this example. The company buys material from two other suppliers, the first one and second one. So again, we have here, for example, two groups. Yes, supplier 1 and supplier 2. So you are buying the material from two other suppliers, and there is given the proportion in a proportion of 40% and 60%. The first supplier charges on average per standard delivery 200,000 Czech crowns. Yes, so this is some expected value, average value, yes, of the standard delivery in Czech crowns, with standard deviation, measures of variability, 20,000 Czech crowns. Yes. The second one, the second supplier, charges on average per standard delivery more, yes, 300,000 Czech crowns, with standard deviation 80,000 Czech crowns. So we have here individual information about the mean, about the standard deviation, and we would like to calculate the total average of payments, yes, the total expected value of payments, and the total variance of payments. So again, we must calculate the total mean and the total variance. Total mean will be weighted mean, and the total variance will be calculated on the basis of decomposition of variance, decomposition of two groups, within group variability and between group variability. So I will rewrite data on the whiteboard and we will solve this immediately. Okay, can you see what I wrote on the whiteboard? Supplier 1 and supplier 2, yes? And we know that in statistics we must use only relative numbers, yes? Relative numbers instead of percentage. So proportions, yes? Proportions must be written like relative number 0.4 and 0.6, 40% share and 60% share, yes? Average amount of money, yes? 200,000 is the average per standard delivery, 300,000, yes? I omitted the zeros for simplification, but I know that interpretation is in thousands. And individual deviation, individual standard deviations, 20,000 and 80,000, yes? So the total mean will be calculated again very easily. Do you remember the formula for the weighted average on the basis of relative frequencies? We can write summation through all j, x, j with stripe, weighted by pj, proportions, so you can see 200 weighted by 0.4 plus 300 weighted by 0.6. You know that multiplication has bigger priority than summation, so 200 times 0.4 plus 300 weighted by 0.6, and the result is 260,000, yes, Czech crowns. So this is the total mean. I will write it, for example, here, x with stripe is equal to 260,000 total average, the total mean. According to formula which you have written, for example, in presentations given by Mr. Hellman or in your formula sheet, I will rewrite here the formula for the decomposition of variance on the basis of relative frequencies. There will be summation through all j, s, xj squared weighted by pj. We need to use individual variances weighted by relative frequencies. So this will be the first part within group variability, and between group variability will be rewritten here, summation through all j, and there we have xj mean minus total mean squared weighted by pj. And that's all, yeah? So between group variability, within group variability, and between group variability. Okay, so I will delete this total mean and we will calculate here sj squared, yes, 20 squared will be 400, yes, and 80 squared will be 6,400. This was in thousand, yes, so I know that this is in millions, yes, so this is important. Okay, now I will solve this. You can see individual variance weighted by proportions. So 400 weighted by 0.4 plus 6,400 weighted by 0.6. Yes, 0.6. Okay, 400 times 0.4 plus 6,400 weighted by 0.6. Result is 4000. So this is within group variability. Yeah? Within group variability. And now this between group variability. So the first mean 200 minus the total mean which I calculated before 260 squared weighted by 0.4. Yes, this is multiplication plus, and there will be another mean 300, yes, minus 260 squared weighted by 0.6. Okay, so please try it, yes. 200 minus 260 squared times 0.4. So the first part, 1440. The second part, there is difference 40 squared times 0.6, 960. So this second part plus 1440 is 2400. Yes, so 4000 was within, this 2400 is between group variability. And in total, if you calculate the summation, yes, 4000 and 2400, the summation will be 6400. The total variance of payments, variance, yes, but we don't know in which units because it's in some squared units, yes, and for us will be better to calculate standard deviation, yes, standard deviation from this variance, because the total standard deviation Sx equal to 80,000 Czech crowns, yes, 0, 0, 0. Do you know original values were in 1000 Czech crowns? So the total variance 6,400, but better for us, better for interpretation, better for understanding, yes, is to recalculate this to original units, original values. Standard deviation 80,000 Czech crowns, yes, the total absolute variability of payments. Okay, so that's all for today. Remember this decomposition of variance, yes, it's very important. So I hope that everything was clear. We finish this topic. This is the end of our third seminar, and next week we will continue. So I wish you a nice day. Bye bye, and I will see you next week.